Okay, this is a video to help with probability genetics problems. At least I'm hoping it will help with probability genetics problems. So, using just the multiplication rule, I'm going to write out three genotypes right here. So you're only going to use this when you have it, when you want to know the specific probability or the probability of a specific offspring's genotype. So if I have these as the parents, they're heterozygous for all the traits, and I want to know what's the probability of having an offspring with this genotype. With the, I'm going to change to this blue color. I think it will show it better. With big T, big T, big G, little g, big B, little b. And so how you do this is you have to figure out the probability for each one. So if I have big T, little t parents, I want to know what's the probability of having a big T offspring, correct? So I have to do the Punnett square for this cross, okay? And if I do the Punnett square for this cross, then I see my probability of big T is 1 out of 4, or 1/4. So I'm just going to write this down here is 1/4. So then I'm looking for the probability of big G, little g. Okay, so we can do this same Punnett square, big G, little g times big G, little g, and we want to know what this probability is. So I can redo the Punnett square over here. And the probability, we have big G, little g here and big G, little g here. So that's a 1/2 probability. So this is 1/4 from big T, so this is 1/2. Now I would like to point out right here, since both of these parents are heterozygous, these boxes are the same. These are both homozygous dominant, these are heterozygous, and these are homozygous recessive. So even though the letters changed, I still could have used this box as my probability. And this is the same thing down here. If I'm looking for this cross and I'm looking for this outcome, this is the same outcome I was looking for before. I'm starting with two heterozygous parents and I'm looking for a heterozygous offspring. So it's going to be the same as this one, and it's going to be 1/2. Okay, so then I just have to do math. 4 times 2 is 8. 8 times 2 is 16. So having these parents, a probability of having this offspring is 1/16. Okay. So now I'm going to get an eraser. And we will do a different problem with parents that are a little different. So I'm going to still big T. Okay, so now we can see that the parents, this parent is heterozygous for everything, this parent is not. So I want to know the probability of having an offspring that is little t, big G, big B, little b. So again, I have to do one trait at a time. So I'm doing my t's first. So big T, little t, with big T, little t, or with little t, little t. So this is okay. So hopefully you see how I filled this in. So what's the likelihood of getting little t? Right here, I see that that is 1/2 times, so I put 1/2 right there. Okay, so now our next one that we're trying to do is big G, little g times big G, little g. And we're trying to get big G, little g. Okay, and maybe you remember this from the last time. because this is the parent that was heterozygous. This is the cross that we had every time last time. And so here's my big G, little g. Okay, so that's 1/2. So I go back over here, my likelihood of big G, little g is 1/2. So now my last one, I'm looking for that big B, little b. And you might think, oh, well, that's 1/2. Well, no, because my parents are different. I have a heterozygous parent and a homozygous dominant parent. So this gives me a different Punnett square right here. So in this case, hopefully you can see that I'm looking for big B, little b, that half of them will be big B, little b, which ended up being the same answer, but we need it to make sure, right? So that's 1/2. And so now we have 1/2 times 1/2 times 1/2. So that's 2 times 2 is 4 times 2 is 8. Is 1/8. Now, this is the way you do this. So, you know, I can make the problem longer, which is what happens, and it really doesn't if I just, you know, add another trait right here. So now I can add another genotype right here. I think I had little t, big G. It really doesn't matter. I can pick whatever I want. Okay, and so now I would do the same thing, but now I've added a 4th genotype. So then I would have 4 numbers to compare. So if I wanted to do big T, little g, big B, big H, little h. So just from experience, I can tell you big T, the big T, little t cross, I'm going to get, the chance of getting that is going to be 1/2. I've done enough Punnett squares that I know that. With these two parents, the likelihood of getting little g is 1/4. Okay. With these two heterozygous parents, the likelihood of getting big B is 1/4. And with these two parents, the likelihood of getting big H, little h is 1/2. And then you multiply, which I would probably need a calculator. We'll say 2 times 4 is 8. 8 times 2 is 16. I'll just get that 16 times 4, so that's 24. So 1/64th, assuming that I did the math correctly. Okay. Now, if I give you, you know, traits, and I think you do this, if this is big T is tall and little t is short, big G is green and little g is yellow, I don't know, big B is bald, little b is hair, I don't know when you'd want bald to be dominant, big H is horns, I'm just making stuff up, no horns, don't know what this creature is or what it would look like. So then I give you a description, and I'm just writing this out down the list. This is heterozygous tall, yellow, homozygous bald, and heterozygous horns. Okay, so now let's say I want to know what's the likelihood of having an offspring that's heterozygous tall, yellow, homozygous bald, heterozygous horns. Okay, so now I have to figure out what these genotypes are. Before I gave them to you, I told you what I wanted. So now I have heterozygous tall is big T, big little t. Yellow is recessive, so that's going to be a little g and a little g. See, my little g's look like S's, I know. Homozygous bald, so bald is dominant, so that's going to be big B. And then heterozygous horns, so horns is dominant, so that would be big H, little h. So I'm wanting to know what's the likelihood, given these parents right here, what's the likelihood of having this offspring? So I can go back and compare my T's. Again, because I'm familiar, I can tell you that that's going to be a 1/2 chance of with a big T little t crossed with little t. And then my G's, that's going to be a 1/4 chance. Okay, heterozygous for both. Homozygous bald, okay, big B little b crossed with big B little b. So I want to know big B, and that's going to be 1/4. And again, this is because I've done so many Punnett squares, I can do these small ones in my head. And so now in this case, big H little h with big H, that's going to be 1/2. And so my probability is, I think this was the last one we had, is 1/64. So hopefully this helps you with the probability.